Hello, I'm Laura Marshall.
And I'm Melinda Rose, and this is Light Matters for January 9th, 2013.
On this week's show, fireflies inspire brighter LEDs, lasers tune common nanoparticles to near IR wavelengths, we talk with a Prism Award finalist, and a fiber laser pioneer gets knighted as we say goodbye to another visionary.
Researchers from Belgium, France, and Canada studied the internal structure of firefly lanterns, the organs on the insects' abdomens that flash to attract mates. They identified an unexpected pattern of jagged scales that enhanced the lantern's glow and applied that knowledge to LED design to create an overlayer that mimicked the natural structure. The overlayer, which increased LED light extraction by up to 55%, could easily be tailored to existing diode designs. Other groups have studied the photonic structures in the firefly lanterns as well and have even mimicked some of the structures to enhance light extraction in LEDs, but their work focused on the nanoscale features. The Belgium-led team is the first to identify micrometer-scale photonic features larger than the wavelength of visible light, but that also improved light extraction. It was a surprising finding, as they expected that the nanoscale structures would be most important. They say what's nice about their technique is that it's an easy process that doesn't require that new LEDs be created. With a few more steps, they can coat and laser pattern an existing LED. The work is published in Optics Express.
Ordinary colloidal gold nanoparticles can be selectively heated on demand by short laser pulses at near-infrared wavelengths. The technique could advance the use of such particles in medical and industrial applications. Counter to the established paradigm, the Rice University discovery allows controlled laser pulses to tune the absorbance spectrum of plain gold colloids, something that was thought to be preset during their fabrication and stayed constant during their optical excitation. The Rice lab showed basic colloidal gold nanoparticles could be efficiently activated by a short laser pulse at 780 nanometers with an 88-fold amplification of the photothermal effect seen with a continuous laser. The strong response of the plasmonic particles to pulsed rather than continuous laser excitation seems to result from the influence of nanobubbles on the particles. Because of their very wide spectra, usually only one type of nanoparticle can be used at a time, otherwise their spectra overlap. But in the new experiment, different types of particles such as nanorods or nanoshells can be mixed together and still be activated individually on demand with pulsed laser light in the same location. Experiments done with clusters in water, in living cancer cells, and in animals achieved the same or better results. The findings are reported in Advanced Materials.
The Prism Awards for Photonics Innovation will be awarded at SPIE Photonics West in February, and as we get closer to the Oscars of Photonics, we will be talking with some of this year's finalists. Recently, I traveled to Westford, Massachusetts, and spoke with Stephen O'Riordan of Linden Photonics, a previous Prism Award winner and a nominee this year in the Test Measurement and Metrology category for their Lindex optics cleaners.
Well, Melinda, we have a new adhesive material which we can apply to the tip of a stick like this and use as a swab to clean female fiber optic connectors. This is a leapfrog advancement in technology because instead of using just a foam or cotton type swab, we are actually using a carbon nanotube-based material that has van der Waals forces that actually attract contamination. They stick it to the swab, and you have to do very little cleaning, and your efficacy is many-fold times what you would get with a traditional swab.
And this product has been nominated for a Prism Award. You guys won for the 2009 Prism Awards with another product that you had. How do you feel about being nominated again?
We're thrilled to be nominated. We got a lot of attention for our nomination, and we were very glad to win in 2009. And we think it's a wonderful program, and we appreciated everybody liking our technology back then for a different product, as you mentioned, and hopefully, they'll see the innovation in this product this year.
Well, good luck.
Well, thank you very much.
It's amazing that something so simple makes such a big difference for sophisticated equipment.
Yes, sometimes the simplest ideas are the best. We'll be talking with more finalists in the weeks to come, so stay tuned for more great ideas and innovative products. In the meantime, you can still watch videos of all 27 of last year's Prism Award finalists at photonics.com/Prism Awards.
David Payne, director of the Optoelectronics Research Center at the University of Southampton, has been knighted by Queen Elizabeth. He was recognized for his extensive contributions in harnessing light in telecommunications, sensing, and lasers for manufacturing. Payne's pioneering work includes development of the erbium-doped fiber amplifier, which is the first practical fiber amplifier and a crucial component in the Internet's ability to transmit huge amounts of data. Its development is regarded as one of the most significant in modern telecommunications. He also led the team that developed the single-mode silica fiber laser and broke the kilowatt barrier for its output power.
In other optical communications news, we recently lost one of the pioneers in the field, Ting-Yi Lee, who died in December. Lee is renowned for his contributions to light wave technology and optical fiber communications during his 41 years at AT&T Bell Labs. During his career, Lee collaborated in developing crucial early understanding of laser cavities and made pioneering contributions to laser-based communication through optical fibers. Lee was respected and loved as an elder among young scientists and engineers, both for his vast knowledge and for his willingness to spend time mentoring, advising, and encouraging young people, and he will be missed.
Well, that's it for this edition of Light Matters, Photonics Media's weekly newscast.
Write to us with your questions or comments at lightmatters@photonics.com.
Thanks for watching, and we'll see you next week.